Good morning, everyone. Hope all is well. Hope everyone's doing all right. Hope you had a great weekend. Let's see, I think everybody is in. All right, so let's see where we are today. Mr. White, I saw your email a few minutes ago. I'll check my schedule and let you know.
Okay, great.
Yep. Also, I know I completely forgot to shoot those videos out to you guys. I'll get them out to you today. I didn't send any videos out. Actually lost a loved one, so kind of threw me off a little bit. So apologize for that, but I'll get that out to you guys today. Videos for the lectures of last week. Just in case anybody was looking for those. Let's see, we did exponents last class, I believe. Anybody have any general questions before we get started today? Very good. Okay. Hold on. Did we do exponents at all last class? Or did I just give you guys a free day? I forgot. Anybody remember?
I think you gave us a free day to study.
Okay. Gotcha. Yeah. I think I was going to do exponents and then I pulled back. Okay, thanks. Appreciate it. All right, so let's look at exponents. 12.1 for you guys. My other class was 6.1. Basically, we're going to talk about exponents and exponent rules. So when you look at 2 to the third power, the regular size number, the 2, is your base, and the number that's superscript up to the right is your exponent. So that means that will be 2 times itself 3 times, which is 8. Now, if you reverse the positioning of those numbers, that does matter. So if I have 3 squared, in other words, 3 is the base and 2 is the exponent, that's 3 times itself twice, which will give you 9. All right. So your base is the number that's going to be repeated. Your exponent is the number of how many times it will be repeated when you do your multiplication. All right. Any problems with that? Let me check something real quick. See something. Okay, yeah. All right, so one of the exercises that you may get right by using exponents, if they give you this right here, 2x times 2x times 2x times 2x, you can rewrite it as 2x to the 4th. problems with that. There's 2x being repeated 4 times, so 2x to the 4th power. All right. Don't worry about this yet. We're going to get there. Somebody asked me a question. All right, here, I was emphasizing when you have parentheses versus not having parentheses and what that means for your exponents. If I have 2x with parentheses to the 4th power, that means the exponent of 4 is being applied to the 2 and the x. If I do not use parentheses, like right here, the exponent of 4 is only applied to the x. So that's why it's going to be real important. And you'll see why when we look at our exponent rules. When you have the parentheses versus not having parentheses, once again, if you have the parentheses, the exponent is applied to everything that's inside of the parentheses. If you do not have parentheses, it's only applied to what is right up against. So same thing here, just emphasizing the difference between having parentheses versus not having parentheses. If I have x, y, z parentheses, and that raised to the 5th power, or parentheses x, y, z raised to the 5th power, that means x, y, z is affected by the exponent of 5. But if I have x, y, z to the 5th power with no parentheses, only the z is affected by the exponent. Any questions on that? All right. So going down here, we're looking at parentheses versus not having parentheses once again. Here we have -4 raised to the 2nd power. But just like I mentioned, if there isn't a parentheses, then the exponent is only applied to what is right up against. So in this -4 squared, the 4 is the only thing that's being squared. So that's why the negative is still sitting on the outside. 4 times 4, and that's -16. Negative is never affected by the square. Going over here, have parentheses, so it means the negative is affected by the square. -4 times -4 is a positive 16. So once again, the parentheses matter. And you see it's the difference between having a negative exponent and a positive exponent. I mean, a negative number or a negative result versus a positive result. All right, next one we have -4/5 raised to the 3rd power. So it's -4/5 times -4/5 times -4/5. But negative to a negative is going to turn positive, so 2 of those negatives will cancel to a positive, but there's still 1 left. So that's why your result would be -64 over 125. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. Any questions? Any questions? Right here, just emphasizing, evidently, student had a question about when you need common denominators, just re-emphasizing the fact that if you're multiplying fractions, you do not need a common denominator. But whenever adding and subtracting, you will need a common denominator. So you always want to make sure you're careful with that. If you're multiplying, all you have to do is multiply across. 2/3 times 4/5 be 8/15. But if I wanted to add those two numbers, I have to find a common denominator, which is 15, and multiply top and bottom by whatever it takes to get a denominator to 15. Same thing here. Then I can add my numerators, so it'd be 10/15 plus 12/15, which is 22/15. So this is not really in this section. That's just me re-emphasizing something that was covered, or should have been covered a while ago. So. Any questions or problems before we get into your exponent rules? All right. So, of course, we're going to talk about them all. Matter of fact, hold on 1 second. Yeah, okay. All right, so your exponent rules. I'm going to give them to you first, so you have them all in one place, and then we will, do examples of each. So x to the m times x to the n. Whenever you have the same base and you're multiplying, whether it be numbers or variables, you're just going to add your exponents. So notice x is our base, just the exponents are different. So we'll add the exponents. Same thing, when it comes to division, similar, but not exactly the same. We have the same base. It's only when you have the same base and you have these exponents, then you would subtract them. So multiplying means you add your exponents. Dividing means you would subtract your exponents. Rule 3, if you have different bases but they're both raised to the same exponent, you can distribute the exponent to each term that's inside and raise that power to each one that's inside the parentheses. Same thing with division. So both of these pretty much are the same thing. You can apply your exponent to each that's inside of the parentheses. Negative exponent. If I have a negative exponent, I can bring it down bottom to turn it positive. Bring it to the bottom my fraction to turn it positive. And if it's in the bottom, I can bring it up top to turn it positive. So 7 is a result of 5 and 6 being introduced. If I have a fraction being raised to a negative exponent, in order to turn that to a positive exponent, I can just flip the fraction. So that's all that these red arrows are for, just saying that 7 is the same thing as 5 and 6, just that it's a whole fraction. So if you have a fraction or if you have a negative exponent and you have your number in your denominator, you can take it up top to turn it positive. If you have a number in your numerator that has a negative exponent, you can take it down bottom to turn it positive. All right. Any questions? Like I say, you might not have any till you see actual, put some numbers on it. All right, last 3. And rule 10, I actually supposed to have it further up on our rule list, but it's all right, as long as I get it in there. X to the first power is just going to be x. So anything to the first power is itself. Anything to the 0 power is 1. And then for our last rule, whenever you raise a power to another power, you're going to multiply your exponents. All right. Everybody good? All right, so let's try this out. All right, so if I have w to the third power times w to the fourth power, we're looking at that first rule. So all we're saying is that if the bases are the same, then we will add our exponents. And the reason being is because w to the third power is 3 w's, w, w, w. W to the fourth power is 4 w's, w, 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 w. So how many w's do we have all together? 7 w's that'll be multiplied to each other. And so that's, excuse me, that's the foundation of all these rules. If you were to expand it out and do the work longhand, you will see that, these are just shortcuts. So that's what we did here. 3 plus 4 will give you w to the 7. Same thing with 2 to the 11 times 2 to the 8th. Add your exponents, that's 2 to the 19th. That third one, y times y to the 9th times y to the 17th. So when you don't see anything, remember we said going back, I think it was like rule 8. No, it might be rule, yeah, rule 8. When you don't see anything, you assume you know there's a 1 there, or y to the first power is always y. So you can't ignore that. So you always got to make sure you include that as a part of your calculation or a part of your addition. So it'll be 1 plus 9 plus 17, which would be 27. All right, any questions before we look at the next one? All right, next one, a times b to the 5th, or just ab to the 5th times a cubed b to the 8th. So that 5th is only be applied to b, and then it's, like I said, a cubed b to the 8th. So what you would do is bring the like bases together. So you're going to multiply your a's, multiply your b's, because outside of that, there's nothing else that you can do. So a times a cubed, bring that together. B to the 5th times b to the 8th, bring that together. Then go ahead and add your exponents. And once again, don't forget that there's a 1 here. So 1 plus 3 gives you 4, 5 plus 8 gives you 13. All right, any questions, any questions? All right, looking at the next rule. So before, when we were multiplying, we added our exponents. When dividing, you're going to subtract. So we have t to the 6th over t to the 4th. That's going to be 6 minus 4, which is t squared. Next one, 5, 10. I said 5, 10. 5 to the 10th over 5 to the 8th would be 5 to the 10 minus 8, which is 5 squared. Now, if it is something simple like this, 5 squared, they are expecting you to go ahead and expand that or simplify it. 5 squared will give you 25. Any problems? Yeah. One more, y to the 15th divided by y to the 8th. That's going to be y to the 7th. All right, any questions before we look at the next set of rules? Mm-hmm. All right, so this was actually rule 10, but we're going to go through it, like I said, in the right positioning. Let that be our third rule. But I actually introduced it to you guys as rule 10, so that's why I was notating that. So x to the m raised to the nth power is multiplying your exponent, so it's m times n. Just one in chat. All right, so here we have s to the 4 raised to the second power. Whenever you have a power raised to another power, you're going to multiply your exponent, so that'd be s to the 8th. All right, here we have 3 to the 10th raised to the 5th power. Multiply your exponents, 3 to the 50th. All right, so now this next one, we have x to the 2nd times x to the 5th raised to the 4th power. So this is the original problem right here. So the first thing you do is what's on the inside, which is x to the 7th times x to the 5th. Add those together, that'll give you x to the 7th. I said x to the 7th, x to the 2nd times x to the 5th. I don't know if I said it right or not. But anyway, add your exponents, that'll give you x to the 7th, and then multiply your exponents here. Because once again, a power to a power, you multiply, and then that'll be x to the 28th. Any problems, any questions? Oh, yeah. All right. Next one. If we have x times y raised to the n power, remember we talked about how you can distribute that not distribute the parentheses, distribute that exponent to each term in the parentheses. That'll be x to the m times y to the m. So the first one we have is negative 2xyz raised to the 4th power. So this is your original problem right here. So we're going to take that 4th power and apply it to each inside the parentheses. All right. So negative 2 to the 4th, x to the 4th, y to the 4th, z to the 4th. And negative 2 to the 4th is negative 2 times itself 4 times, which will give you a positive 16. And then x to the 4th, y to the 4th, z to the 4th. You know, they are what they are. Any questions? All right, same type of deal here. This is the original problem. 5x squared y to the 7th raised to the 3rd power. So that 3rd power needs to be applied to each that's in the parentheses. So it's 5 cubed x to the 2nd cubed y to the 7th cubed. All right. So 5 cubed, that's 5 times 5 times 5, which is 125. X to the 2nd cubed, raise a power to a power, multiply your exponents, so that's x to the 6th. And then y to the 7th cubed, multiply your exponents, it's y to the 21st. Any problems? And so these, yes, someone said something?
So if the number is outside the parentheses, you times it by the number inside. But if there is no parentheses, you add it.
Now, let me make sure I got you. We say the number, which number, when you look at this, which number are you referring to?
So like 3 is on the outside and then x to the 2nd, you would, since it's a parentheses, you multiply that.
Right, because you'll be raising a power to a power, right.
But if there was no parentheses, you'd add it.
Well, that's as long as the bases are the same. So in other words, if I had an x right here, then yes, you would add the x to the 2nd and the x to the 7th. You would add these. But if since they were different bases, I had an x and a y, then I wouldn't be able to add them together.
Okay.
Yeah. All right. Anybody else before we move to the next one? And when it comes to these rules, you want to make sure you put the practice in, because a lot of times learning them and using them, learning them will come by using them. And so you don't want to put yourself in position of, I'm gonna study these rules, and then get to a test or get to an assignment. Now you're trying to figure out how to do it. So you want to get into your homework and put the practice in, and the more you use them, the more you'll know how to use them, and that's where it really comes in. It's not more so I'm gonna study when to use these rules. Is I put the practice in. When I use them, I know when to use them. All right. So rule 4, x over y raised to the n power. So you're applying the n power to both numerator and denominator. So if I have 2 over 5 raised to the 3rd power, that's 2 to the 3rd power over 5 to the 3rd power, which is 8 over 125. All right.
How'd you get 8?
2 times 2 times 2. Yep. Oh, where my pen? Yep. It's 2 times 2 times 2. So 2 times itself 3 times. 2 times 2 is 4. Then 4 times 2 will give you 8. Same thing here. 5 times 5 times 5. So 5 times 5 is 25. Multiply 5 one more time will give you 125. All right, everybody good? All right, so the next one, 2x cubed over y to the 5th raised to the 2nd power. So that's square. as second power has to be applied to each term in the numerator. So there's going to be 2 squared, x to the third power, or x cubed squared. Then also it's applied to the denominator, and that is y to the 5th squared. All right, so 2 squared is 4, 2 times 2. And then once again here, power to a power, you multiply your exponents. That's 6. Power to a power, multiply your exponents, and that'll be 10. Any questions? All right, this is our original problem. For the next one, x to the 6, x to the second raised to the 6th power times x cubed divided by x to the 7th raised to the 2nd power. All right, so multiply your exponents right here. X to the second raised to the 6th power would be x to the 12th. Power to a power, you multiply. Now right here, because we have like bases, we can go ahead and add our exponents because we multiply like bases. So 12 plus 3 gave you 15. And then subtract your exponents because of division. And that'll be x to the 1st power, which is just x. Any questions? Any questions? All right, let me erase some of this stuff. All right, original problems right here. 3cd squared times 2cd cubed raised to the 3rd power. All right. So first thing you want to do is get rid of that cube on the outside of the 2cd. So we can apply the cube to each term on the inside. So that's what we got going on over here. 3cd squared is still the same. Nothing affected that. But then we have 2 cubed, c cubed, and then d cubed cubed. All right, from there we can simplify this quantity or these terms. So 2 to the 3rd power is 8, 2 times 2 times 2, and then right here, exponent raised to another exponent means we're going to multiply. So now we have this result. All right, so now we'll couple together what we can simplify. 3 times 8, we can multiply those together. C times C cubed and D squared times D to the 9th. And then bring those all together. 3 times 8 is 24. C times C cubed, add your exponents, that's C to the 4th. D squared times D to the 9th, add your exponents, D to the 11th. Any problems? All right, I believe we almost finished with this section. Now scroll up, everybody good? All right, next one, we talk about the zero exponent. X to the 0 is equal to 1. Anything to the 0 power is equal to 1. But once again, you have to be careful with what's being applied to the 0 power because they're going to, play with these parentheses versus not having parentheses and so on. So see right here, 4 to the 0 power is equal to 1. Negative 4 to the 0 power with parentheses is also equal to 1. But notice what happens when you don't use parentheses. The 0 is only applied to the 4. So that means the negative is not affected by the exponent. So the result would be negative 1. Any problem with those three? So x to the 0 power is 1, like we already mentioned. Here, be careful because parentheses is not in existence. So the x is the only thing that's affected by the 0 power. So that's why the x turns to 1. So the result is going to be negative 4. But in here, at this last one, 4x is being affected by the 0 power. So the whole thing is equal to 1. So the parentheses versus not having parentheses really matter on what is being affected by your exponent. So make sure you're careful. Any questions on any of those? Let's scroll up. Everybody good? All right, so we're not going to do negative exponents yet. That is going to be 12.5 for you guys. This book breaks it up. So we'll come back to it. But here we can at least do 12.2, which is just adding and subtracting polynomials. Yours called adding and subtracting polynomials. All right, so a polynomial is just an expression that has variables, operations, exponents, etc. So x plus 5, 15x squared, 3x cubed plus 7x minus 9 are all examples of polynomials. All right, your terms are separated by plus and minus signs. That dictates how many terms that you have. All right, sorry about that. So we have our three terms here, 3x cubed, positive 7x, and negative 9. Notice that if something is positive, it stays positive. Something's minus sign has a minus sign attached to it, and that's considered negative, so you keep that. You don't lose it. All right, looking at more terminology. Your coefficient is the number in front of the variable. So when I look at 3x cubed plus 7x minus 9, and if I'm scrolling up too far, let me know. Um, 3x cubed, the coefficient is 3. Talking about the number that's in front of your variable. For 7x, the coefficient is 7, and then negative 9, the coefficient will be negative 9. Any questions? Once again, this is just terminology. The degree of your term is the exponent on the variable. So the degree of 3x cubed, is 3 because of the exponent, not because of the number in front. So I always meant to change one of those numbers, but I keep forgetting to go back and do it. But yeah, but 3, and then here there's a 1 here that they assume that you know because you don't see anything. So that's 1 for your exponent, and then nothing here. So your exponent is 0. Any questions? Any questions? All right, next one, the degree of the polynomial is the largest exponent in your polynomial. So the degree of this polynomial will be 3. Any questions? All right, constant, the number that's not attached to a variable. That's just be that negative 9, that minus 9. Any questions? If they ask you about descending order, arranging your terms from largest to smallest according to your exponents. So you notice you look at your exponents, starting off with 7, going down 6, 3, 1, and then no exponent at all. And that's the one we normally use, writing your exponents or writing your terms in descending order. All right, and then writing in ascending order, just in case they were to ask, that's arranging your terms from smallest to largest, it's increasing. Descending is decreasing, ascending is increasing. So arranging your terms from smallest to largest according to your exponent. They could ask that of you, but like I said, what we normally do is descending order. Any questions? All right. So a monomial is just one term. So an example of that is 7x. Remember, once you introduce a plus or minus sign, now you're making more than one term. Binomials, 2 terms. 7x minus 5 is an example of that. 7x is a term. 5 is also a term. Trinomials, 3 terms. So negative x squared plus 7x minus 5. And polynomial, just 4 more terms. Just generally, they all call, referred to as polynomials. But if you're talking about being specific, you got your monomial, binomial, trinomial, and then polynomial. Poly is many. So 4 more terms. All right, any questions on the terminology before we look to add them and subtract them? All right, let's see. All right, so let's go ahead and add them. So the way we'll be able to add and subtract, the way we'll be able to do so is by what we call like terms. If they're considered like, then they have to have the same variables, same exponent of variables, same amount of variables. So when we look at this column over here, 5x and 3x will be considered like terms. 10x squared and negative 17x squared, like terms. They both have the power 2 on the x. Negative 39x squared y, 1 on 1 x squared y. Both of them have x squared y, so they're like terms. And then even regular numbers that do not have any variables at all, considered like terms. If you change anything in the variables or the exponents, then they are not alike, and you will not be able to add them or subtract them from each other. So here are examples over here of those type of scenarios. 5x and 3, one has x, the other one doesn't, so you will not be able to add them or subtract them from each other. 10x squared, negative 17x. One has the power of 2 on the x, the other one doesn't, so you will not be able to add them or subtract them. Same thing here with the power of 2. If you take the power of 2 off of one of your off of the x, even though they both have x and y, they both don't have the power of 2 on the x, so you will not be able to add them or subtract them from each other. All right, any questions on that? Scroll up, everybody. All right, so here's just different variations of that 5 and the x and that 3x, showing you different scenarios when you would be able to add them versus when you wouldn't be able to. So 5x plus 3x, common terms, like terms, so you just add the numbers together, which will give you 8x. Here, 5x plus 3, one has x, the other one doesn't, so I cannot add them together. That means that expression is already in lowest terms. There's nothing else I can do with that. 5x plus 3y, same thing. One has x, the other one has y. I cannot add them together, so that expression is already in lowest terms. Five x squared plus 3x squared. We both have x squared, so that means I can go ahead and add them together. Notice I'm not adding your exponents. That goes 5x squared plus 3x squared goes to 8x squared. So the x squared part stays continuous throughout the whole problem. All you do is add the 5 and the 3. And then last one, if one has a power of 2 on the x and the other one doesn't, you cannot add them together. Any questions on what you can add together, subtract from each other, and what you cannot? So these same rules apply to subtraction as well. Any questions? All right, so I'm gonna go ahead and try this out. We have 7x squared y plus 20x squared y minus 8. All you would do is combine the like terms, and whatever's not like, you just leave it as a part of your expression. So we have 7x squared y and 20x squared y. Those are your like terms. So you add those together, and that'll be 27x squared y. The minus 8 is still in the back, so you just go ahead and bring it down bring it down as a part of your answer. All right, any questions? All right, so the next one, negative 3c cubed plus 5c squared minus 7 plus 11c cubed plus 6c squared plus 3. And all you're going to do is combine your like terms. Combine your like terms. So when you look at negative 3c cubed plus 11c cubed, that would be 8c cubed. 5c squared plus 6c squared, 11c squared. Now the 7c does not have anything it can combine with, so you just bring it down. Same thing with 3, just bring it down. And this would be your final result. Almost simplified expression. Any questions? All right, same thing happens for the next one. 4w squared minus 2x plus 3w squared minus 4x squared plus 6x. All right, so 3w squared, 4w squared is 7w squared. Negative 2x plus 6x is positive 4x. And then this negative 4x squared, you just bring it down. Couldn't combine with anything. So it's just the last piece of our expression. All right. So now we're looking at subtraction. Subtraction is the same thought process. It's just that the minus sign adds an extra step. And that's what we did right here. So we have negative 4p to the fourth plus 5p squared minus 3 minus the quantity of 11p squared plus 4p minus 6. So whenever you have that minus sign sitting in front of us, parentheses, you have to distribute it. And that's going to change every sign that's in that parentheses. So the first set of parentheses is not affected, but every sign in the parentheses that follow has to be changed. So if I were to write it all out, I have negative 4p to the fourth plus 5p squared minus 3. Like I said, all of those signs are the same. Now we have minus 11p squared minus 4p plus 6. Any problems with that transition once we distribute our negative sign? So once we do that, now it's just about combining your like terms. We have negative 4p to the fourth. There's nothing I can combine with that, so you go ahead and bring it down. Remember, we're going to write our answers in descending order. So p to the fourth is the highest exponent that we have. There is no p cubed, but then we have 5p squared, negative 11p squared, which gives us negative 6p squared. Hold on 1 second. All right, and then p to the fourth minus, not p to the fourth, minus 4p. Couldn't combine that with anything, so you just bring it down. Then the same thing with negative 3. Oh, we got negative 3 and positive 6. Sorry about that. Adding those together will give you a positive 3. So you just have to be careful with what you have like terms, where you have like terms, where you don't. And like I said, they are expecting you to write it in descending order. So you're making sure your exponents, you know, from largest to smallest. All right. Any questions? All right, so for this next one, same type of deal. We have a squared minus 2ab plus 7b squared minus negative 8a squared minus 6ab plus 2b squared. All right, so distribute the negative to each in the parentheses that follows. So let me erase this stuff. Got a squared minus 2ab plus 7b squared. Then that's minus sign gonna change to plus 8a squared plus 6ab minus 2b squared. All right, so now we're looking to combine the like terms. We have a squared and 8 squared, or a squared and 8a squared, which would be 9a squared. Then we have minus 2ab, 6ab, so that's 4ab. And then 7b squared minus 2b squared, which would be 5b squared. Any questions? Everybody good? Everybody straight? All right. So that's it for adding and subtracting your polynomials. That's 2 sections right there, so we don't necessarily have to go into another section. I'll give you guys a chance to process, what we've talked about today. Any questions on anything? Any questions on anything? Everybody good? Everybody straight? All right. So that's it for today. Like I said, I'll get those lectures from last week out to you today as well. Like I said, I did death in the family, so that kind of threw me off this weekend. But I'll get those lectures out to you guys today. And if you sent any emails this weekend, I'll make sure I answer those today as well. So if you guys are good, I'm good. I will see you next class, and y'all have a good one. All right, everybody take care.